Difference of squares. So difference of squares were those weird questions that we saw that didn't have a middle value, where the b was equal to 0. So what you're going to look at is right there. Your sum is equal to 0. So what can multiply to be negative 16 and add to be 0, Aaron? Negative 8. Yep, 8 and 8. So 8 and negative 8. What can multiply to be 64? Sorry. No, those add to be 16. We want to multiply to be 16. Sorry, Aaron. Gosh.
4.
Yeah, it's 4 and negative 4. 4 and negative 4 multiply to be negative 16 and add to be 0. How about negative 64? 8, negative 8 this time, right? Yeah. And finally, 25, Murph. Yeah, the pattern is you can take the square root of these things. And it would work out. That's why they're called perfect squares. So the polynomial these would come from would look like this. X squared minus 16. X squared minus 64. What would this last one look like? X squared minus 25, yeah, man. So when you see polynomials that look like this, that middle value's gone. It doesn't exist anymore. You only have 2 terms. You can't take a greatest common factor out anymore, but you're still being told to factor it. You need to look for a difference of squares, meaning that these are your new numbers. You wanted things that would multiply to be a times c, 1 times negative 16, and add to be 0. What if we had 36 here? Matthew. 6 and 6. 6 and negative 6. 6 and negative 6 adds up to be 0. 6 times 6 adds up to multiplies to be 36. But it doesn't work, does it? Because if you put negative 6 and 6, it multiplies to be negative 36, not positive. The point I'm trying to make is if you see something like this, it can't be done. You can't find 2 integers that'll multiply to be positive and add to be negative. It's not possible. 2 positive integers can't add together to be negative or to be 0. Matthew. Pardon? Sum's always 0. And why is the sum 0? Why is that the sum we're looking for? Taylor. Leo. Because that's what your b value is. There is no middle term. It doesn't exist. Yes, Matthew.
So, like, no matter what the term is going to be like.
Yeah. If you can square root the product and there's no middle term, you have something called the difference of squares. And you want it to look like this in factored form. That polynomial right here factors into that. This will be one of those ones that'll pop up on tests, and it kind of separates grades. It takes you from a 90 to an 80, or an 80 to a 70, or vice versa. If you get these, you can go from a 60 to a 70. It's just a quick jump. So what would this one look like in factored form? Michael. Yeah? X minus. Yeah, Michael. X plus 8 times x minus 8. These really aren't any more difficult. It's just you got to think the sum is 0 because there's no middle term. What's the last one going to be, Carter? You got it, man. They're really not that tough, right? It's just about figuring out that you want to add up to be 0. Because when you don't see something, it's hard to imagine it's there. So, here's a nice laid out set of steps on how to factor these per difference of squares. You're going to draw your brackets. You know you want binomial times a binomial. So you know you're going to have brackets. You take the square root of your first term. What's our first term here? What's the first term? Yep. X squared. What's the square root of x squared, L? X. Put it right here. So the square root of your first term goes here and here. Yes, Matthew.
X plus 3.
Yep. And then your next two terms, one's a plus, one's a minus. And it's just the square root of your second term. Goes there, goes there. 3 and 3. That's the first time we've done this. Any questions on how we got there, Kendall? Same as the diamond. So if the diamond method works out,
Let's see. So this is kind of option.
yeah, it's an easier way to just kind of skip through it. Yeah, so what goes on the top of the diamond for this question, Kendall? And what goes on the bottom, Kendall? Yeah. And what goes on the sides? Or you can follow this new method if you saw it as a difference of squares. And just go, the square root of the first term is x. The square root of the second term is 15. Both get you the same answer. Lucia? You good? Yeah. Easy? Good. Okay, so we should be able to fly through these. Set up your brackets. What's the square root of the first term, Joe? 4 what? 4t. 4t. So you have to do the square root of the coefficient and of the term. Sorry. The coefficient and the variable. And what are the next things, Matthew? Yep.
14 plus 7.
You got it.
Oh my gosh.
Next one. What's the answer to the next one? Actually do it. Don't just wait for the answer. If you put this,
10.
It's 10 plus y, 10 minus y.
yeah. Yeah, you got to put it that way. So the y is now the second term, right? Because it was minus y squared. So you have to have a minus y somewhere. Next one. 2x plus 5? 2x minus 5? Who agrees? Why don't you agree, Dawson? Because it's plus 25. Meaning what, Dawson? Meaning you can't do it.
You're wrong. Oh.
So you're right. You're right, because you can't get two positives that would multiply to be positive and add to be a 0. Not possible. So if you see a plus sign, it's not a difference of squares. So it's not factorable. Matthew, please.
8 plus 3.
Perfect. Emma. The difference is that, so you're right, the constant is positive here, and it is positive here. But the leading variable is negative. Whereas this leading variable is still positive. That's the difference. So everything is positive in this one. These ones have one positive and one negative. One positive, one negative. One positive, one negative. You can't have both be positive. It was Matthew then Taylor.
You know how on second positive, could you write it where it's
Please. Just wait, Michael. Go ahead, Matthew.
Could you write it so it's like, you'll give a plus, so you don't have to write pluses, can't write negative.
So negative and negative? So what's minus 5 minus another 5? Multiplied together is 25.
Yeah.
But added together is minus 10. So it still doesn't work. Taylor? Same question? Michael? It's not factorial because of that plus sign. So what you need to do here, Michael, if you set up your diamond, right? What goes on the top of the diamond? 4 times 25. A times C. So 100. Perfect. Move forward. In front of Matthew. Please. What goes on the bottom of the diamond? So what could go on the sides? Negative 10 and 10 adds to be 0, but it does not multiply to be 100.
Got it.
The point is you would never find anything to go on the sides. That's why it's not factorable.
So would you like revolutionize math and find a way to do it?
No, because you can't find a way to do it. That's a waste of the life. Okay, any more questions about this? Right.
What turns your negative into?
Ooh, good question. So if we had negative x squared minus 4, and you make your diamond, what goes on top for that question? It'd be negative 1 times negative 4. So that would be plus 4. 0 on the bottom. What things can multiply to be 4 and add to be 0? 2? 2 and 2 would multiply to be 4, but it couldn't add to be 0. Yeah. Yeah. So the negative, if you have 2 negatives, it gives you the same issue. You can't find 2 numbers to the side of that diamond. Joe?
Will the not factorable thing ever be on a test?
Yes. Yes. And the trick is to be able to identify it quick enough that you don't waste the whole test doing it. Yeah, exactly. Any more questions? Factor if possible.
So I guess
Well, probably. Let's do the first one. What's the square root of the first term? Square root. Not divided by 2. What's the square root in? Square root of the first term. You do. 12 what?
12p.
12p what? Q. 12p Q. What's the second terms? Plus 2, negative 2. Perfect. B. Is it a difference of squares? Why not? Matthew, why not?
Because you can, or I guess you could, but it wouldn't be the same one.
Because you can't take the square root of 3 or x cubed. But Taylor, do you have something? Yeah, you can't take the square root of a cube. Ella. There we go. First step you always got to do, take out your greatest common factor. That is still your first step. So what's the greatest common factor? No, it's not 3. Ella, what is it? It's 3x.
Okay, yes, I realize that was 27 was next, so it has to be. I don't know when this one.
You took out the 3x. Now you can do your difference of squares, right, Ella? It would still be the same thing, yeah. The first step never changes through this entire unit. Greatest common factor. Always. So this 3x, we took it out of that and out of that. So when we did 3x cubed divided by 3x, it left us with x squared. When we did 27x divided by 3x, it left us with negative 9. No, because this right here is now a difference of squares. So, Matthew, what's the difference of squares going to be? Oh, go ahead, sorry.
What if it was like 3x minus
3x cubed minus 27? Then you couldn't take the x out, right? So it still wouldn't be a difference of squares.
3x brackets x plus 3.
Perfect. Yeah. Nope, doesn't matter. You go either way. The reason I always put the plus first and the negative second is because sometimes this negative will be another difference of squares. So you're going to keep doing work. And that way you have room to add on to the end instead of trying to add on into the middle. Brady. You won't get that. Yeah. Because it's the exact same. So you'd be right either way. That's why you won't get that as multiple choice. This one. What's the first step? Can't do it? Right, but what's the first step? Always. Greatest common factor. What's the greatest common factor? Jared. Yeah, buddy. Take out your 2. You're left with x4 minus 16. Now you have a difference of squares again, right? So what's the square root of this first term? The square root of x to the power 4 is what, Brady? And here's the problem I was talking about, why you always put the negative second. Because this right here is another difference of squares.
So what would you do, just roll it up?
So now you have to rewrite that one. So these first terms don't change. Because we can't factor them anymore.
Because now it's squares.
Right. But that is a difference of squares. So what would you rewrite that second one as? Got it. That is going to be one of the trickier, bigger mark questions on a test. You always have to look at your result and see if you can factor it further. I hate when I have to write on a test, keep factoring. Because I know you can do it, it's just you didn't see it. So always check that. Okay, there's nothing on this sheet, but there's one more I want to do for you. Is that a difference of squares? What's the square root of 1? 1. So you can do it. So this, when you factor it,
That's still.
is that the answer?
No.
It's still factorable. That is another difference of squares. So keep going. It'll only go on until you run out of x's. Because what's the square root of x? We don't know. It's not. It's definitely not something we know. Eric?
It's x6, 1 and 5.
No. Because what's the square root of x exponent 5? It is something. We can rewrite it.
5 over 2.
Yeah, it's, right? That's from our very first unit. And 5 divided by 2 isn't a whole number. So we can't do it.
So it has to be even.
Yes, ma'am.
Unless it's a cube root. But that's no longer different.
But that's not difference of squares. It's difference of cubes.
Oh,
And that's possible. So if you had, right?
Yeah. And then you have like 27.
No, you ran into a problem still.
It,
Yeah.
whatever.
Because if you had, you'd be adding to get to 0. You can't have 3 terms added to get to 0 that are all the same. So you can't do cubes. You could do 4 stuff. 8. Leave me alone. Any questions about difference of squares? Okay, because yesterday we spent the class not working on